A good day to everyone who's watching. In our lesson today of algebra, we are going to start with linear equations. Linear equations, they are those whose unknown in that equation is to degree 1, or the highest power of the unknown that we are supposed to find has an index of 1. So when we go to the examples, solve the following equations. Part A is right there. Remember, we talked about the expansion. So those brackets, they are going to require us to expand. Then we also talked about the simplification, that is collecting like terms. We shall collect like terms and then simplify and get the value of the unknown. So when I open brackets, this is going to be 5 times x, then 5 times 3. 5 times x, that is 5x, minus 5 times negative 3, that is negative 15, is equal to 3 times x, that is 3x, 3 times 1, that is minus 3 there. Then now I'm going to collect like terms. The unknown, this side, I'm going to bring it this other side. Then the negative 15, I take it the other side. So this one is going to be 5x minus 3x is equal to the negative 15 this side. When it crosses equal sign, it's going to gain the positive there, then a minus 3. So this other side, we have 2x when we subtract there. Then the other side, we have a 12 there. Then to get the value of x, we need to divide both sides by 2, because 2 is still attached to our unknown. Divide this side by 2 and that side by 2. So I get the value of x as a 6 there. Part B, we are going to solve for that unknown. 5 all over x plus a third is equal to 8 all over 9. Now here, because we have fractions there, we need to first eliminate them. How do we eliminate them? By getting the LCM of all the denominators in the equation. That is the LCM of x, 3 and 9. So thereafter, we are going to multiply it throughout the whole equation. So LCM of x, 3 and 9, that one is 9x. Then I'm going to get the 9x, I multiply it there, there and there on the next step. So this is 9x times 5 all over x plus 9x times 1 all over 3 is equal to 9x times 8 all over 9 there. So when I complete this one here, you can see that the x is going to cancel out. Then we shall be left with 9 times 5. So that one gives us 45. Then this one, when I simplify this one here, the 3 reduces 9 to a 3. So 3 times x times 1. And that one gives me plus 3x is equivalent to the 9 is going to reduce the 9. And then we shall be having x times 8 to have 8x there. So now I've eliminated my denominators there, or I've eliminated the fractions there. Now I'm going to collect like terms. The 3x, I'm going to take it the other side. It is positive. The other side is going to be a negative. Minus 3x is equivalent to 45 there. Just this statement, someone can rewrite it as 8x minus 3x is equal to 45. So the two there, they are the same. Right hand side, the other side is equal to the left hand side, this side. So that means that even that part there is also equal to that side there. So this one here, I'm going to be having 5x is equal to 45. Then I divide both sides by 5 to get my value of x as a 9. Part C, we are still solving for the unknown in the equations. Even here we have a fractional equation. So we are going to eliminate the denominators by first getting the LCM of all the denominators which are in the equation there. This 4 here is just all over 1. So the LCM of 3m, 1m, and 5 there. So when you try to get the LCM, that one's going to be 15m. Then I'm going to get 15m. I multiply it there, 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 and also there. So this is 15m times 4 all over 3m. Then minus 15m times 4 all over 1 plus 15m times 2 all over m is equal to 15m times 4 all over 5. Simplifying here, the m is going to cancel, the 3 is going to reduce 15 to 5. So 5 times 4, that's going to be 20, minus 15 times 4, I get 60m. Then the m is going to reduce the m there. 15 times 5, that is 30, is equal to, here the 5 is going to reduce the 15 to 3. So 3 times m, then times 4, that's going to give me 12m. Now I need to collect like terms there. So I'm going to take my negative 60, the other side, it is negative, then it's going to become positive. So 12m plus 60m. Then when I add this to that, I have the 350. The other side, this is going to be 72m is equal to 350 this side. So I divide both sides by 72, then I divide both sides by 72. I end up getting my value of m as 25 all over 36. I have reduced the 50 all over the 72 to 25 all over 36. Part D, we are still solving for the unknown. We still also have fractional equation there. We need to get the LCM of all the denominators in the equation. This 2 here is all over 1. So the LCM of 4, x minus 3, and then a 1. The LCM there is 4 into x minus 3. I'm going to get this one. I multiply it throughout each term in the equation. This is going to be 4 into x minus 3, then times 7 all over 4, then minus 4 into x minus 3, then times 5 all over x minus 3 is equivalent to 4 into x minus 3, then times the 2 all over 1. The 4 reduces the 4 to 1, so 1 times this bracket, then times 7. So that's going to be 7 into the x minus 3. Here, this bracket of x minus 3 is the one that cancels out. And then I remain with 4 times 5, which gives me minus 20 is equal to, the 2 will multiply the 4 to have 8 into x minus 3. Opening brackets, so 7 times x is 7x, 7 times negative 3 minus 21, then minus 20 is equal to 8 minus x, 8x, 8 minus negative 3 there is minus 24. Now I'm going to collect like terms, that is put unknowns on one side of the equation and then the figures on the other side of the equation. So the 8, taking it this side, this is going to be 7x minus the 8, because this side has been positive. When it crosses equal sign, it becomes a negative. Then these two here, they give me negative 41. So when they cross equal sign, it's going to become positive 41, then minus the 24 there. So subtracting this side, I'll be having negative x is equal to positive 17 the other side. But I need to remove the negative by dividing through by negative 1. Then finally I get the value of x as the negative 17. Part E, we are still solving for the unknown. Now we have the unknowns there in our numerator, and then we're going to first put brackets on them, get the LCM of the denominator, multiply it throughout each term in the equation. So the LCM of 3, 5 and 30 is 30. So I get my 30 times the 2m minus 5 all over 5. I've said I'm going to put brackets on those things there, plus 30 into m minus 4 all over 3 is equal to 30 into m plus 14 divided by 30. This 5 here is going to reduce the 30 to 6. So this is going to be 6 into 2m minus 5. Then the 3 is going to reduce 30 to 10. 10 into m minus 4. The 30 is going to reduce the 30 there to 1. So that's going to be 1 into m plus 14. So you can see now I've eliminated all the denominators in the equation there. Now I need just to expand and then collect like terms. 6 times 2m, that's going to give me 12m. Then 6 times negative 5 there gives me negative 30. Then positive 10 times m there, that is 10m. And then minus 40, then is equal to m plus 14. Part F, we find the value of the unknown there. The LCM of all these denominators is 12. So 12 times k plus 1 all over 3. I've said I'm going to be putting brackets because this one is different from 12 times k plus 1 all over a 3. Someone is going to end up multiplying 12 by the k only, yet this 12 multiplies the whole of that. Minus 12 into 2k plus 3 all over 4 is equal to 12 times 5 all over 6 into k plus 1. The 3 is going to reduce 12 to 4. So that is going to be 4 into k plus 1. Then minus, the 4 is going to reduce 12 to 3. That becomes 3 into 2k plus 3 is equal to, the 6 is going to reduce 12 to 2, and that is going to be 2 times 5, which is 10 into k plus 1. So now I'm going to open brackets. So this is going to be 4k plus 4, then minus 3 times that is 6k, minus 3 times that is going to be minus 9, is equal to the 10k there plus the 10. The reason as why I always put brackets there, you can see that the sign here will always affect what is inside the bracket. So if you don't put them, you will just multiply this negative 3 times the 2k alone, and then you will be having that one there as a positive, yet it should be a negative. So adding negative 6k to 4k, that is the minus 2k. 4 minus the 9, that's going to be minus 5, is equal to 10k plus 10. So collecting like terms, I'm going to bring the 10k this side, then the negative 5, I take it the other side. So it is going to be 5 plus the 10 there, then the 10k is going to be a minus 10k this side, because the other side it has been a positive. When I add those ones there, that's going to give me negative 12k is equal to 15. I'm going to divide both sides by negative 12. So divide this way by negative 12 and that way by negative 12. This side I'll be left with a positive k, and it will be equal to a negative. When you reduce that fraction there by 3, you will be having 5 all over a 4. Example 2. Now we are going to look at WORDY problems. Remember when we formed linear algebraic expressions? So we are going to use that idea there, we got there, to form a linear expression, and then now we form an equation and solve it, and then thereafter on we answer the question accordingly. So James is twice as old as Peter, and John is 7 years younger than James. If the sum of their ages is 23, find the age of each person. So if I let Peter's age be M, I have Peter there, James, and John. So from the question, they are saying that James is twice as old as Peter. If my Peter is M years, then twice M is the age of James, so this is 2M. Now, they have said that John is 7 years younger than James. That means that on the age of James, I'm going to reduce there 7. The reduction is a minus. So that's going to be 2M minus 7. Now, they have said that statement there, that the sum is 23. So the total is 23, right? Now I need to get the sum of these ages of these three boys. Then thereafter I equate it to 23. So this gives me m plus 2m plus 2m minus 7. This is equal to 23. You see, now I have formed a linear algebraic equation of which I'm going to simplify and then find the value of m. Then thereafter I answer the question accordingly. So when I add the m here, I'm having 5m minus 7 is equal to 23. I take 7 the other side. This is going to be 5m is equal to 23 plus 7 because this side has been a negative. So this is 5m is equal to, when I add the other side, this gives me 30. Then when I divide both sides by 5, I'm going to get my value of m as a 6. So Peter's age is 6 years. James's age is twice that one of Peter, that is 2m, and this is going to be 2 times 6 to get 12 years. Johnny's age is 2m minus 7. So the 2m, we have got it as 12. So 12 minus 7, this one here is going to give me 5 years. So Johnny's age is that. That one is the one for James. And finally that one is the one for Peter. The question wanted the age of each person. Example 3. In a test, Ben got twice as many marks as Anna, and Carol got 8 marks more than Ben. Together, they got a total of 223 marks. What is Anna's mark? If I let Anna's mark be n, then I put my n right there. Ben got twice as many marks as Anne, so Ben got 2 times n. Carol got 8 marks more than Ben. That is, you get Ben's marks, you add there 8. Then they say they got a total of 223. So I'm going now to add their ages to be equal to 223. So this is n plus 2n plus 2n plus 8 is equal to 223. When I add the unknowns there, they're going to give me 5n plus 8 is equal to 223. I'm going to take the 8, the other side of the equation. So this one here, 5n is going to be equal to 223 minus 8. So this is going to be 5n is equal to 215. Then I divide both sides by 5, and that way by 5. My value of n is going to be 43. So Anna's mark is equal to 43.